Hello everyone. Today we're looking into the fascinating world of spacecraft recovery, exploring the critical differences and shared challenges of splashdowns and touchdowns. The successful return of a spacecraft from orbit is a complex endeavor, culminating in either a splashdown or a touchdown. Each method presents unique challenges and advantages, with a choice often dictated by the spacecraft's design, mission objectives, and the availability of suitable landing sites. This video will explore the characteristics, historical context, key technologies, and environmental considerations associated with both splashdowns and touchdowns, including examples from India's burgeoning space program. Let's see, what is splashdown, its historical context and mission. A splashdown involves a spacecraft re-entering the Earth's atmosphere and deploying parachutes to slow its descent before landing in a body of water, typically an ocean. The spacecraft is designed to be buoyant and withstand the impact with the water surface. Recovery teams are then dispatched to retrieve the capsule and its occupants. Historically, splashdowns were the go-to method for spacecraft recovery, particularly for early US manned programs like Mercury, Gemini, and Apollo, which saw their capsules return to Earth with ocean landings. Today, commercial ventures like SpaceX Dragon continue this tradition, splashing down in the Atlantic or Gulf of Mexico. India has also demonstrated this capability with a successful space capsule recovery experiment, SRE-1, in 2007, and it's the planned recovery method for ISRO's future Gaganyaan human spaceflight program, with initial tests already validating this approach in the Bay of Bengal. Additionally, Indian astronaut Shubhanshu Shukla recently gained direct experience with a splashdown during the Axiom 4 mission aboard a SpaceX Dragon capsule. For splashdowns, several key technologies and procedures are essential. A heat shield is crucial for surviving the extreme temperatures of atmospheric re-entry. A multi-stage parachute system, including drogue and main parachutes, dramatically slows the spacecraft's descent. Attitude control thrusters precisely orient the capsule during re-entry and parachute deployment. Once in the water, flotation devices like airbags or internal buoyancy systems ensure the capsule remains upright. Beacon and communication systems guide specialized naval recovery teams consisting of ships and divers who then locate, secure, and retrieve the capsule and its crew. For splashdowns, the main advantages include a large, flexible landing area and the cushioning effect of water, which reduces the need for extensive ground infrastructure. However, disadvantages involve complex sea recovery operations susceptible to weather, the risk of capsule drift, potential saltwater corrosion, and crew discomfort from impact and motion sickness. On the other hand, a touchdown involves a spacecraft landing on a solid surface, usually a prepared runway or a designated landing zone. This method typically requires highly precise navigation and controlled descent, often utilizing wings or retropropulsion. Touchdowns have been the preferred recovery method for spacecraft designed for reusability or those requiring highly specific landing sites. Historically, the US Space Shuttle performed unpowered glide landings on runways. Similarly, Russia's Soyuz and China's Shenzhou capsules use parachutes and retrorockets for propulsive soft landings on land. Commercial ventures like Blue Origin's New Shepard and SpaceX's Falcon 9 have revolutionized spaceflight with highly precise vertical powered landings on land. Beyond Earth, robotic missions to Mars have used various touchdown methods, including airbag landings, sky cranes, and powered descents to safely deliver probes to the planet's surface. India has also made significant contributions. ISRO's Chandrayaan-3 successfully achieved a soft landing on the Moon, showcasing extraterrestrial touchdown capabilities, and its Reusable Launch Vehicle Technology Demonstrator (RLVTD) program has demonstrated autonomous land-based runway landings for future winged spacecraft. For a successful touchdown, several crucial technologies and procedures work together. A heat shield is vital for re-entry vehicles to withstand extreme atmospheric temperatures. Aerodynamic control surfaces like wings and rudders allow winged spacecraft to maneuver precisely during descent. Upon approach, landing gear deploys to absorb impact, while retropropulsion or thrust vectoring systems use engines to enable a controlled, often vertical, soft landing. Precision navigation and guidance systems, including highly accurate GPS and radar altimeters, ensure pinpoint accuracy to designated landing strips or pads. Finally, ground support crews are essential for immediate post-landing safing and servicing of the spacecraft. Touchdowns offer several key advantages. They allow for greater precision in landing location, providing direct access to ground facilities, and they facilitate the reusability of winged vehicles or propulsively landed stages. This method also avoids complex maritime recovery operations, potentially reducing costs and generally offers higher crew comfort due to a smoother landing. However, touchdowns come with disadvantages, including the need for extensive ground infrastructure like runways or landing pads, a higher precision requirement that leads to smaller acceptable landing zones, and greater stress on the spacecraft structure for non-propulsive landings. Furthermore, weather conditions like crosswinds or fog can significantly impact landing feasibility. The future of spacecraft recovery is largely driven by the pursuit of reusability, with a strong preference for land-based touchdowns, especially vertical propulsive landings. Companies like SpaceX have already demonstrated the cost-saving benefits of reusing rocket stages. While splashdowns will remain relevant for certain crew capsules, such as India's Gaganyaan mission, the overall trend in spaceflight is shifting towards precise, land-based returns, exemplified by ISRO's ongoing RLVTD program, to achieve more sustainable and economical access to space. Both splashdowns and touchdowns are vital spacecraft recovery methods, each with unique benefits and challenges. Thanks for watching. Don't forget to like, share, comments, and subscribe for more incredible tech videos.